Hi guys, you're probably wondering what in the world is Miss Kaufman doing on her knees, bellied up to this table. Well, before I introduce today's lesson, I want to show you what the kids at school are going to be doing first. And if you have the stuff to do this at home, it's actually kind of fun, so you could probably do it too. Let me tell you what you need. I'm just using one of these little clear plastic Solo cups. And I put a really good, almost brand new card on it. You can't use one that's very old because if it's very ruffled, it won't work. And a nickel. I'm gonna place the nickel on that. And I'm gonna try real hard to flip that card out from under that nickel, where the card goes that way, but the nickel drops in the cup. Now, I don't always get it on the first try, so if I mess up, I'm just gonna try it again. Oh, see, I messed up. I did it perfect a minute ago, of course. Let's try it again. Sorry. There you go.
There's the card.
There's the card.
There's the
There's
nickel.
the pin, or the nickel. It dropped in there. You may have seen people on magic shows doing something similar with a table, and they put a real silky smooth tablecloth on there and put a whole bunch of dishes and stuff on there, and then they yank it real hard. Now, I would have dumped them all if that had been me because the cup went down. But the idea is to move the card real quick, but not drag the nickel with it. And if you want to try that at home, it's pretty fun. Okay, it might take a while. Okay. Now let me crawl up here and we'll get on with the lesson, okay? All right, so turn the slide on. What you just saw was an example of Newton's first law of motion. And it says that an object at rest will remain at rest unless acted on by an unbalanced, or I like to call it an outside force, okay? And that an object in motion will continue with constant speed and direction unless acted on by an unbalanced force. And that's a real fancy way for saying something that's sitting still is going to stay sitting still unless a force acts on it. In this picture, you can see that's a soccer ball. It's sitting still, and then somebody kicks it. That causes it to go in motion. Now, the next part of this probably doesn't make quite as much sense on Earth, but I'm going to explain it to you. It says that an object in motion will continue with constant speed and direction unless acted on by an unbalanced or an outside force. In this, they're just showing that whoever kicked the ball made goal. Okay, so the net stopped it. Most of you know, though, if you're kicking a ball or if you're throwing a ball up in the air, it is going to come back down to the earth, okay, because there is a force acting on it. It's the force of gravity. However, if we could get clear away from Earth's gravitational field, and we wanted to kick a soccer ball into space, that soccer ball will continue going at the same speed and in the same direction, literally forever, unless something got in its way, some other force. Maybe it got pulled into the gravity of a star or a planet, or a comet hit it, or an asteroid hit it. So that's not typically something we really think about here on Earth, because we're used to the gravitational field of Earth acting on every single object. All right, let's go over here. We're going to get a few definitions down. And this first one is number 12 on your study guide. Newton's first law of motion. It is sometimes referred to as the law of inertia. And that's kind of a weird word. We're going to get its definition here in a minute. It states that an object in motion will remain in motion unless acted upon by an outside force, and an object at rest will remain at rest unless acted upon by an outside force. So I'm going to give you just a couple minutes. You can pause here if you need to get that definition. All right. So there's only one other definition on this thing, and that is right here. Inertia is a tendency of an object to resist any change of, hold on a minute, motion. There we go. The inertia is closely related to the mass of the object also. Now, you might be wondering why I've got this photograph here on this particular screen, and when I'm in class, I'm probably going to ask the kids what they think's happened here. Just about everybody can figure this out. Miss Whiteside, what does it look like to you?
Well, it looks like he was riding that bike and the bike stopped, but he didn't.
Yeah, this guy's, and if you've ever been to like a motorcycle track, or a lot of times they do this. They put tires around the inside of the fence so that if somebody has a wreck, maybe they won't be injured so bad because their body's this stuff's got a little give to it, whereas, you know, I don't know, the fence probably does too, but the concrete does not. So one good thing about this guy is you notice he's wearing a helmet, right? Because if he wasn't wearing a helmet, he might end up going head first into this fence and breaking his neck. At least he's got some protection. You'll notice he's wearing an outfit that's probably made with leather so that he gets less road rash if he does crash. But here's the deal. This guy's been going around this track, and then something happened, and instead of making the curve, he probably started going too fast, because occasionally that happens. That happens with people who are driving fast with cars too. Matter of fact, just recently you may have even heard of Tiger Woods having a pretty bad car wreck in California, and it was determined that he was driving 90 miles an hour in a 45 mile an hour speed zone, and it curved, and his car could not take the curve. Okay, he was going too fast, and he did just basically what this did, only with him it was the whole car with him in it. So basically this guy hit these tires. Notice his motorcycle stopped, but he did not. And that is an example of Newton's first law of motion.
Those tires are the outside force on that bike.
Yeah, for sure. And nothing stopped him. One of the things we'll talk a little bit about when I'm teaching this in class is how this relates to seatbelt laws. One of the reasons that it is a law now for everybody riding in a car to belt up is because this will happen inside a car if you are not belted up and your car comes to an abrupt halt. In other words, there's a wreck. You will continue to move in the same direction at the same speed, because that's what Newton's law, first law of motion, says. It states that an object that's in motion will remain in motion unless acted upon by an outside force. Okay, so if you're sitting in the car with no seatbelt on and you're going 55 miles an hour and somebody pulls out in front of you, even if whoever's driving slows it down as best as possible, you're going to hit. And a seatbelt would be the force that would keep you from going through the windshield.
Yep, but
people don't do well going through windshields, okay? Most folks don't live to tell about it. So that is why I've got this guy here. I'm hopeful that in this scenario he was all right when it was all finished with, okay? Okay, after you have got these two definitions, you've listened to this instructional video, I'm going to put 3 YouTube video clips on there that kind of just explain other examples of Newton's first law. I want you to watch them all 3. They're pretty entertaining, okay? All right, thank you.